In the fascinating world of quantum physics, particles challenge our understanding of reality by behaving as both particles and waves. Imagine you're throwing a stone into a pond. You'd see ripples spreading out, much like a wave. Now, picture firing a bullet, which travels in a straight line, just like a particle. But what if I told you that in the quantum world, things aren't so straightforward? Let's take electrons and photons, the building blocks of our universe. These elementary particles are known for their particle-like properties. An electron, for instance, has a definite mass and charge. A photon, the particle of light, can knock electrons off a metal surface, demonstrating particle-like behavior. But here's the twist: these particles also exhibit wave-like characteristics. They can interfere with each other, create patterns of light and dark, and even diffract around obstacles, much like waves do. It's as if our stone thrown into the pond is also a bullet traveling in a straight line. This perplexing behavior is what physicists refer to as wave-particle duality. It's the idea that every particle or quantum entity can be described as both a particle and a wave. It's a fundamental concept in quantum mechanics, a branch of physics that deals with phenomena on a very small scale, such as atoms and subatomic particles. So, how can something be both a particle and a wave at the same time? Well, it's not that simple. Wave-particle duality doesn't mean that particles are waves one moment and particles the next. Instead, it suggests that particles have properties of both waves and particles, and that they can exhibit these characteristics under different circumstances. This dual nature of particles as both waves and particles is what we call wave-particle duality. It's one of the most mind-boggling concepts in physics, challenging our everyday experiences and forcing us to rethink our understanding of the physical world. So buckle up as we dive deeper into this fascinating mystery of the quantum universe. One of the most famous experiments in quantum physics, the Double-Slit Experiment, revealed the wave-particle duality in an astonishing way. The experiment was simple in design, yet it unveiled a mind-boggling aspect of our universe. It involved shining light or firing electrons through two slits and observing the pattern on a screen behind. What made the experiment so fascinating was the unexpected result. If light and electrons were merely particles, they should have created two bands on the screen, each corresponding to one of the slits. But instead, an interference pattern emerged, a hallmark of wave behavior. This pattern, a series of light and dark fringes, suggested that particles were not just particles, but also waves that could interfere with each other. But the real twist came when the experiment was performed one particle at a time. Even then, the interference pattern persisted. It was as if each particle, be it a photon or an electron, went through both slits simultaneously, interfered with itself, and somehow knew the path it should take. This was the first empirical evidence that particles could also behave as waves, an idea that was as strange as it was revolutionary. The double-slit experiment was a turning point in our understanding of the quantum world. Its results led to the development of quantum mechanics, a theory that describes the behavior of particles at the smallest scales. It challenged our intuitive understanding of reality, forcing us to accept that at the quantum level, particles can exist in multiple states at once and only settle into one state when observed. This experiment was more than a scientific curiosity. It was a profound revelation about the nature of reality itself. It told us that the universe at its most fundamental level behaves in ways that defy our everyday intuition and understanding. It was a stark reminder that there is still so much more to learn about the cosmos and the laws that govern it. The double-slit experiment opened the door to a whole new understanding of the quantum world. Wave-particle duality is not just a curious phenomenon. It forms the cornerstone of quantum mechanics. This duality, this ability of particles to behave both as particles and waves, has far-reaching implications. It's like a superhero with a dual identity, except in this case, our superhero is an electron or a photon, and its superpowers are the abilities to be both a particle and a wave simultaneously. But why is this important? Well, wave-particle duality is a fundamental concept that underpins much of modern physics. It's the key that unlocks the door to the quantum universe. And it's the reason we have quantum mechanics, a branch of physics that describes how particles behave at the microscopic level. Consider Heisenberg's uncertainty principle, for instance. This principle, a cornerstone of quantum mechanics, states that you can't precisely know both the position and momentum of a particle at the same time. The more accurately you know one of these values, the less accurately you can know the other. This principle is a direct consequence of wave-particle duality. If particles behaved only as particles, we wouldn't have this uncertainty. Similarly, wave-particle duality is fundamental to the concept of Schrödinger's cat. This famous thought experiment suggests that a cat in a box could be both alive and dead at the same time until someone looks in the box. This strange scenario is possible because of wave-particle duality. The cat's state is like a particle's wave function, a mathematical description of its quantum state. It's only when we measure, or in the case of the cat, look in the box, that we collapse this wave function, forcing the particle to behave as a particle, not a wave. So wave-particle duality is not just a quirky feature of the quantum world. It's a fundamental principle that shapes our understanding of the universe. Wave-particle duality is the key that unlocks the door to the quantum universe. The wave-particle duality isn't just a mind-bending concept, it's at the heart of groundbreaking technologies. This duality is a cornerstone of modern physics, and it has some incredible real-world applications. Let's start with electron microscopy. In the world of microscopy, the resolution of an image is limited by the wavelength of the light used. In a traditional light microscope, this wavelength is quite large, limiting the resolution. But electrons, thanks to wave-particle duality, can also behave as waves with much shorter wavelengths. This allows electron microscopes to achieve a much higher resolution, enabling scientists to explore the world at the atomic level. Then there's quantum computing. Quantum computers leverage the principles of quantum mechanics, including wave-particle duality, to process information. Unlike classical computers, which deal with bits that are either zeros or ones, quantum computers work with quantum bits or qubits. Qubits can be both 0 and 1 at the same time thanks to the superposition principle, a consequence of wave-particle duality. This allows quantum computers to perform complex calculations at a speed far beyond the reach of any classical computer. In the world of telecommunications, wave-particle duality is key to the development of optical fibers. Photons traveling through these fibers display both wave-like and particle-like properties, enabling the transmission of data over long distances with minimal loss. And let's not forget about solar cells, where particles of light or photons knock electrons loose, creating an electric current. This photovoltaic effect, the basis of solar energy, is another practical application of wave-particle duality. Understanding wave-particle duality is not just for theoretical physicists, it's crucial for the technology that shapes our world. From the microscopes that uncover the secrets of atoms to the quantum computers that could revolutionize technology, wave-particle duality is more than a paradox. It's a tool that's paving the way for the future. As we wrap up our journey into wave-particle duality, remember that this is just one of the many fascinating concepts in the quantum universe. We've unlocked the mystery of how particles can behave as both waves and particles simultaneously, delved into the historic Double-Slit Experiment, and discussed the profound implications of this duality in the realm of quantum mechanics. We've also looked at how this seemingly abstract concept is at the heart of groundbreaking technologies, from electron microscopy to quantum computing. Our universe is truly a wonder, filled with phenomena that challenge our perception and understanding. By exploring these concepts, we join the ranks of curious minds who continue to push the boundaries of knowledge. So don't forget to like, share, and subscribe to Investigating the Universe. Your support fuels our cosmic journeys and keeps you in the loop with the wonders of the quantum world. Until our next cosmic adventure, stay curious and keep exploring the universe. Thank you for joining us today on Investigating the Universe. We've journeyed through the fascinating world of quantum mechanics, diving into the enigmatic concept of wave-particle duality. This paradoxical concept, where particles like electrons and photons exhibit both wave-like and particle-like properties, has been one of the most intriguing aspects of our exploration today. We began by unlocking the mystery of this duality, taking you through the perplexing notion that objects in the quantum world don't necessarily conform to our traditional understanding of physics. Instead, they play by a different set of rules. exhibiting behaviors that, on the surface, seem to defy common sense. From there, we ventured into the historic double-slit experiment, a pivotal moment in the world of quantum physics. This experiment, performed with particles of light known as photons, revealed for the first time the dual nature of particles. It showed us that these particles could behave like waves, creating interference patterns, yet also act as individual particles, a concept that continues to baffle scientists and enthusiasts alike. We then explored the far-reaching implications of wave-particle duality in the realm of quantum mechanics. We saw how this concept is deeply woven into the fabric of modern physics, underpinning principles like Heisenberg's Uncertainty Principle and thought experiments like Schrödinger's cat. This duality has challenged our perception of reality, forcing us to rethink our understanding of the natural world. But wave-particle duality isn't just a theoretical concept. We also touched on its real-world applications, from electron microscopy, which leverages the wave-like properties of electrons to create high-resolution images, to quantum computing, a groundbreaking technology that could revolutionize our world. This duality is far from being an abstract idea. It's at the heart of cutting-edge technologies that are shaping our future. As we wrap up this exploration, we hope that you found this journey into wave-particle duality as thrilling as we have. The quantum world is a strange and wonderful place, filled with paradoxes and mysteries that challenge our understanding of the universe. And wave-particle duality is just one of the many fascinating concepts that make quantum physics such an intriguing field of study. But our exploration doesn't end here. The universe is a vast, uncharted territory waiting to be discovered. And each new discovery, each new understanding, brings us one step closer to unraveling the secrets of the cosmos. So we encourage you to keep feeding your curiosity, keep questioning, and keep exploring. Because every question you ask, every concept you grapple with, brings you one step closer to understanding the incredible universe we inhabit. Remember, your support is vital to our cosmic journeys. Your likes, shares, and subscriptions help us continue our exploration and bring the wonders of the quantum world to a wider audience. So, if you've enjoyed this journey into wave-particle duality, please consider supporting us in whatever way you can. We hope that you'll join us again as we continue our cosmic adventures. There are countless mysteries waiting to be discovered, countless questions waiting to be answered, and we can't wait to explore them with you. So until our next journey into the cosmos, stay curious, keep asking questions, and never stop exploring. The universe is a vast, wonderful place filled with mysteries and wonders beyond our wildest dreams. And together, we'll continue to unlock its secrets, one cosmic adventure at a time. See you soon on our next cosmic adventure.